Hello, AP Stat students. It's been a while. I wanted to go over number 9 on the homework because I've been noticing a number of different answers. I figure it would probably be a good idea if I talked about it a little bit with you so you could get a better feel for linear regression. So we're going to jump into notability now. Alright, you'll notice I have this set up for you already. So we're looking at speed and fuel used. And they're trying to see, does fuel consumption of a car change as speed increases? So we're trying to see if, we're trying to see if the fuel's going to change when it comes to the speed here. So what I ended up doing was the first thing they asked us to do was use a calculator to help sketch a scatter plot. Hopefully you did that. I know some people attempted to do it by hand. Nothing wrong with that. I just recommend for linear regression, stick to the calculator. So you'll notice down here, I did go about doing that. So you'll notice that down here, I had speed as my independent variable, my dependent variable being fuel consumption. Why? Because we're trying to see if fuel consumption is dependent on speed. We're trying to see if there's some sort of relationship here. So you'll notice that I went over it in pink just because the dots weren't super clear. And looking at it, the one thing that struck me, and hopefully it struck you a little bit too, you didn't really get a line here. I wouldn't necessarily call this a linear relationship, or at least entirely linear. Some people refer to this as a parabola almost. It's not quite a linear relationship. One observation you could make, maybe if you divided it up right here down the middle, and we're going to talk about that in a little bit, you could say that maybe here you're getting more of a negative correlation, and here you're getting a positive correlation. Once you get to about, see, I'm judging here, it's probably about 60 miles an hour. So before 60 miles an hour, you notice it's kind of a negative correlation, and then after 60 miles an hour, you're getting kind of a positive correlation. So if you want, you could kind of take that observation or approach, but just based on what we're seeing here, it's not, I wouldn't call it linear, because if it was linear, you'd be able to see a really clear pattern. Like maybe you'd get all the dots clustering around the line like this. Or I mean, it doesn't have to be super strong, but you'd get a really clear line out of it. And let's see, I'm just trying to erase this stuff. I mean, if it was negative, then you'd probably expect to see something like this, where it's all kind of clustering around that negative line here. We're not getting that. So you can say, I mean, ultimately, I can tell you it's going to be a weak linear correlation, at least. Now, is there some sort of correlation? I could see that. I mean, there's some sort of pattern, definitely. But I wouldn't say it's a linear correlation. And that's what we're really focused on here. So let's go about answering these questions. So A, done. We just did that. For part B, describe the form of the relationship. Why is it not linear? Explain why the form of the relationship makes sense. Okay, so we already talked about it a little bit. It's not exactly linear. You'll notice that maybe up to about 60 miles an hour, you get kind of about a negative linear correlation. And then from 60 miles an hour up, you get a positive correlation. Now, it says, why does this make sense? I'll be 100% honest with you. I'm not I'm not comfortable with the mechanics of cars. Maybe some of you are. But what I'm just noticing here is it looks like you're consuming less fuel once you get kind of like that 30 to, let's see, it's about 30 here. Yeah, like 25 to 60 miles an hour. The fuel consumption is on the lower side, which I guess makes sense because when you're driving a car, you're driving on the slow side, chances are you're not going to be using that much fuel. On the low side here, when you first start it up, like going really slow, yeah, I guess you could see, you kind of need the fuel to start it up. And then, it gets more efficient as you're traveling, then yeah, okay, I can see that. You're using less fuel. And then once you start driving fast, like hopefully you're not getting to 125 miles an hour, but in this case they did, looks like you're using a bit more fuel here. So I guess that does make some sense. It's pretty negative. You get a negative correlation when you're driving, efficiently or on the slow side. And then when you start driving fast, you get a positive linear correlation. But overall, I wouldn't say in general, if you're, get rid of this line or that condition, I wouldn't call this a linear correlation. And, I gave you my best guess based on driving. Maybe those of you who have better feeling for auto mechanics can give me a better answer for that. C. It does not make sense to describe the variables as either positive or negatively associated. Why? Again, as I was explaining before, you're not necessarily seeing them cluster around the line of best fit here. It doesn't really seem to follow a pattern. Again, up to about 60 miles an hour. Maybe you could say it's negative, over 60 miles an hour, positive correlation, but up to that point, if you're looking at it as a whole, I'm not really seeing that because again, you'd probably seeing everything cluster around or kind of give you a nice line of best fit. We're not seeing that here. And that's the big thing I really want you to pull from this. And let's keep going. Is the relationship reasonably strong or weak? Explain your answer. Here's the approach I would take. I'd say it's a pretty strong relationship. It's not necessarily linear, but it's a strong relationship because you can use this basically to predict about what the fuel consumption would be. As you're going from like 0 to 60 miles an hour, looks like the fuel consumption goes down. And then once you get above 60 miles an hour, fuel consumption goes up. So, I mean, there is a relationship there. I just wouldn't necessarily call it linear. So I wanted to take some time to go over this question because I noticed a lot of different answers, and I figured it'd be good to talk about it a little bit. If you have any questions, you can always shoot me an email at, my school address. You can send it to my YouTube address, statsgamash@gmail.com, or you can just post a question on Schoology. But hopefully this helps you a little bit. We're going to be focusing a bit more on linear regression, so you'll get more comfortable with the terms. And you can watch my video comparing Donald Trump's hand size to other people's hand size to see if there is a correlation. That's good where we start to use some of the terms a bit more. This is just kind of like a nice little intro. So hopefully this